Good evening, all. We'll start with today's session. So, our training topic for the day is HAZOP study. Let's meet the trainer for the day. Our trainer for the day is Mr. Sridhar TB. He is working as a lead engineer in process and technical safety with iFluids Engineering. He has 24 plus years of work experience in commissioning, operations, and project management in the field of oil and gas. His key areas of expertise includes HAZOP and hazard study, SIL assessment and verification study, hazardous area classification, quantitative risk assessment study, FNG mapping, and emergency response disaster management plan. We heartily welcome you to the session, sir. I kindly request everyone to mute yourself. We'll be having a doubt clearing session at the end of the training. Thank you. I request Sridhar TV sir to take forward the training.
Thank you, ma'am. Thank you for that.
I request others to please mute your mics.
Good evening to all. I hope my screen is visible to everyone.
Yes, sir, it's visible.
Okay. Today's topic is process safety and HAZOP. We're going to deal with process safety. Safety is one of the key important role in oil and gas industry. We need safety is very important because it is governed by three factors. One is everyone knows it is money, okay, economic reason. Another one is the moral reason, and then one is governed by the law. Why? Because everyone is bound by moral duty, to protect others. The second one is if you do not follow, then you will end up in losing your asset. That is, you will be losing money. Another one is governed by the law safety, because various countries have various rules and regulation that will be governed, and which has to be strictly followed. These are the three reasons why safety is followed. Okay, let's see why safety. What is safety? Safety is nothing but a freedom. What IEC says is safety from unacceptable risk. Okay, freedom from unacceptable risk. What is freedom from? There is no, we can say unacceptable or acceptable. See, there are certain kind of risks that will be accepted. Okay, for each and every country, there are certain risks which will be accepted. That is called as an unacceptable risk that can be. Is what is defined. Everyone says, whenever we go, some of the people, some people have the attitude of not following safety, or they think it is, very expensive. If anyone thinks that safety is very expensive, they can, like people say, try an accident, right? Because, the accident costs almost 10 times more than investing in safety. We will be, losing around 2 million people per year, which is not acceptable, because as I said earlier, everyone has a moral duty, and the employers are, bound to protect their employees. And moreover, the employees are coming there, are paid to work, and they are not paid to die. I think someone mic is not muted. Kindly mute it. It will be disturbing others. Okay. We have and see this graph represents the various causes of accidents. Okay, specification, not following the specified rules or regulations, or even the material or anything that is specification that has to be followed is not followed, is contributes 44%. And during commissioning or changes, you have accidents causes is 21%, operation and maintenance causes 50%, and installation and commissioning is 6%, design implementation is 50%. These are the statics that gives the accident causes. Okay. Hazardous event is when we say hazardous event, that it is nothing but the release of energy or anything, any potential that has potential to cause harm to the people, environment, okay, asset, and the reputation. In short, they call it as peer. You can remember this word peer. Fruit. The peer word is nothing but the fruit, right? But it also represents P for people, E for environment, A for asset, and R for reputation of the organization. Okay, so or mostly R will not be taken into risk, because why? Because our reputation that cannot be quantified even to certain extent. That's why R will not be considered. Okay, risk. What is risk? Whenever we always say risk. Whenever we say I can take this much quantity of risk, risk is nothing but the product of consequence and frequency. Okay, consequence is nothing but what will happen, the extent of the damage is the consequence that you describe. Frequency is nothing but the probability, or you can say likelihood of the thing that is happening. That is called as risk. It is a two word, consequence and frequency. Okay. Hazard identification. See, to be successful, to prevent any process hazard, any hazard, it is determined, it is very imperative to, identify the hazard. Okay. There are different tools in across the, ages that has been introduced to identify the hazardous situation as prevent the risk. So we will be one of the such tool is the HAZOP. There are other tools, AZIT, NVID. There are many tools, right? All those tools are used to identify the hazard and mitigate it. See, typical incident that occurs is nothing but UISSA, toxic gas, okay, explosion, combustible, anything that damages people, environment, or the asset is nothing but an hazardous event. Okay. What is PHA? Okay, overview of PHA. See, PHA is nothing but is a wider term that is used to identify a process hazard analysis. It is a wide term. There are different techniques that is being used. This technique is used to identify any process, any hazard in a process. Okay. This is not done by a single person. It is carried out by a team of people. Okay, multidisciplinary action. It is not a one-man show, but it is led by one person, but it is contributed by different discipline people to come together and identify the hazard in it and come out with a recommendation to prevent it. Okay, it mainly the success depends upon the experience and knowledge of the team. If the team is not having a good, person with experience or knowledge people, and they're sure that PHA is not going to work well. Okay. Next one. Let's see what is the overview of the PHA assignment. Okay, there are PHA. When I say PHA, I have seen different methods, right? HAZID, HAZOP, QRA, all these things are process hazard analysis, NVID. Okay, all these things are one of the PHA, what if analysis, bow tie, all these things are PHA. Okay, so these can be conducted at when people will ask when to conduct an HAZOP. HAZOP is conducted at many stage, almost 6 stages. Even feed stage, they conduct it. After detailed engineering, they conduct it. During, commissioning phase, during startup, and now every year after Nowadays, it is in India, it is mandatory to conduct HAZOP every 5 years. Okay, so it can be conducted at any time during the phase of commissioning, startup, or during the running of the plant. If even when you do some changes to any system, you want to bring out some modification to a system, then you carry out the PHA, that is HAZOP, anything that you do, you can carry out the PHA at any point of time. There is no time frame like that. You have to carry it only during this time. Okay, there are what I said is before, what can go wrong, how likely it is, and what is the consequence is nothing but altogether put together is process hazard analysis. Okay. Okay, history of PHA. Now see HAZOP, like for example, HAZOP. For now, because we are dealing with HAZOP, so I'll talk about HAZOP. HAZOP was developed in UK by Imperial Chemical over 30 years ago. Okay, over the years it has undergone many changes. There is always improvement added, and it has been a lot of guided words have been changed. Now the program is well structured and robust to identify the process hazard. And as time process, now we use modern techniques like software to carry out this study. Okay, there was law also legislated in USA, and like in India, we use we OSD. It is a requirement to carry out every 5 years. PHA. Let's see process safety. See, there are two types of safety in basic. One is process safety, and another was this function safety. Like whenever I go, I tell this process safety is nothing but you see a tiger. The tiger is when it hunts, it is hides himself. It camouflages. It hides in a stealthy way without without any without giving any symptoms. But whereas a lion, that is occupational safety, if you see it is, you can see the lion in the open field. Okay, you can easily identify. Like when you go to a plant, you can see people, they don't wear gloves, they don't wear, helmet or whichever, they are not working properly, they are not following, ergonomics. You can identify all those things, or, occupational safety. It is like, like lions in the open field, they lie in the open field and they act. But whereas that process safety, it is hidden, right? You don't know when it happens. But the accident caused by process safety is much more catastrophic, more expensive. Okay. Okay. Process safety philosophy. Okay. So see, when the for process safety is considered, there are different layers like control protecting the process safety. One is process. The process, safe process by itself is a layer that protects the process safety. Another is control and monitoring, that is your BPCS, basic process control system. Then you comes your prevention, then your mitigation, on-site emergency, off-site emergency. These are all the layers have been put for process safety. Okay. Approach to process safety. Okay, our aim, see, always when we talk about approach to process, our aim is always to eliminate the hazard rather than controlling it. See, when you cannot control the hazard, then you go for substitution. Okay, when you cannot engineering methods, when you cannot do that, okay, substitute or anything, you go for engineering methods. When you cannot do it, then you go for administrative controls. When you cannot do, then you go for personal safety, PPE, all those things to protect yourself. This is the approach to process safety. Okay. There are, there are many safety layers that have the potential to create worst consequences. Okay, some of the incident that has happened in process safety is nothing but your Bhopal incident, okay, and Piper Alpha incident. All these things are some of the example for how, the process safety accidents led to a catastrophic incident. I will just tell you how one of the incident, everyone is aware of Bhopal incident since we are in India. It is one of the worst accident ever that has happened in the mankind so far in regarding to process hazard. I'll tell you one of the example is Piper Alpha. Okay, that is also one of the worst accident that happened. How it happened, I'll just give you a brief explanation in 5 to 10 minutes. Okay, what happens is that it is a offshore platform. It is in England. Okay, that is giving or that is protecting almost 1/3 of the oil requirement of the UK London. So what happens? They are producing oil such a huge quantity. Okay, so what happened is one day they are taking the pump out for maintenance, that is pumping the condensate. Okay, when they want to take the pump out for one of the pump for maintenance, there is to be two pumps. One is running, another is standby. Okay, they want to take the pump that is on standby for maintenance to isolate. What happens? The mechanical team comes in, isolate the pump, and take the pressure relief valve for the maintenance. Once the valve is taken for maintenance, what happens? Once they take it out, they have to fix some flanges on it, right? To blind it. So what happens? Mechanical put a flange which is not of the rating. So they box it up, they close it, and they leave the and they leave the plant. They carry out the work. End of the day, they just keep it isolated and leave the area. Okay, they didn't mention keep the permit, what happened, or follow anything, and they leave. The night shift people come in, they run the plant, and suddenly the pump that is running develops. There is a snag in the pump, and the plant has to be shut down. So it is a huge production. Loss will be there. So the supervisor is instructing his team to go and check the standby pump. The team comes in, they check, they say it is isolated, means fire is not running. So they just go through the log to know what happened. Okay, they were not able to find any follow-up. So they think job has continued, they completed, they just start the pump. When they start the pump, the flange that they have put in the place of the safety valve is not of the rating, it is not as per the rating. So the huge condensate escapes and there is a fire beside, gets ignited from the equipment beside, auto equipments, and there is explosion. More than 180 people die in that accident. There were several reasons behind it. The living quarters was closer by, there was no fire wall protection, and it was over manned. All those things were there. That were the thing. So see, this is one of the reason, for one example, how much, if you don't know, follow the process safety, all those things, then it is catastrophic. The whole platform got burnt. That is the thing. Okay, what is the strategy? Is how to control it. Is one is inherent, one is passive, active, and procedure. These are the strategies to control the process. Inherent is nothing but to eliminate the hazard by substitution, as I stated. Right. Another is passive. Okay, without any active functioning of any devices. Okay, control the hazard by active functioning of any devices, any control valves. Okay. Next is active, to control the hazard through system design, monitoring, specific condition by an event. Next one is procedure, okay, that you put in place. That is administrative thing to control this. Okay, this is the hierarchy of controlling. Okay. Okay. Process safety design phase. See, even there are various HSE reviews, like during the design phase that has to be carried out. AZID, AZON, what if analysis, quantitative risk, HAZOP. These are all carried out during the design phase of the process safety and design phase. And these are safety at execution phase, pre-startup safety review, safety audit, following the procedure. All these things we carry out during the execution phase. Okay, and another one is operational phase, is the safety audit, management of change, revisiting the HAZOP 5 years once. I said these are the method to carried out during the operational phase. Okay, as I said, this Bhopal is one of the disaster. You can just go through it in the 3-part video. It is there given. You can see how it has led to a disaster. Everyone should be knowing this by time, because whoever does a chemical engineering or anything, they will be sure to know this disaster. Okay. See, there are PSM is nothing, process safety management. See, there are different, standards. Some people follow 14 elements, some follow 18, some follow 22. All those things are different elements that, carried out to maintain the safety of the process of the plant. Okay. Okay, these are this is a simple graphical representation how this PSM is represented. Okay, there are 18 pillars. Okay, and this is the base foundation of the pillar is managing the risk, learning from the experience, understand the hazard and risk, commit to process safety. These are all the base of the fundamental upon which the pillar stands, and least the roof of the process safety is there. Okay. Center for Chemical Process Safety, they have 20 elements. Okay, ours have OSD is having 18 elements. Now we will talk what is HAZOP. Okay. This is our main topic for today is hazard and what HAZOP is nothing but hazard and operability study. Okay. See, HAZOP is nothing but a qualitative method. See, whenever I say qualitative, because I am going to define the risk in a defining it by a words. Okay. And I say quantitative, I am going to define it by describe it in terms of numbers. Okay. So HAZOP is nothing but a qualitative, sometimes it is semi-quantitative method. Mostly it is a qualitative method. It is search for what we do in HAZOP. We search for the hazard and causes for the hazard. Our aim is not to eliminate hazard. It is to find the hazard and find what is the recommendation to minimize it. Okay, this is the main aim of the HAZOP. Okay, as I said, how when HAZOP can be carried out, normal operation, during plant commissioning, okay, portion or maintenance, all those things can be done for the HAZOP. Okay, what is the standard that we follow usually? IEC 61882 is the standard that is being followed. Okay, international standard. OISD 206 is nothing but the replica of IEC 61882. Okay, this is the standard that is being followed by the to carry out the HAZOP. As I said, I have described one of the case study. So here it's also one case study. See what happens in this Buncefield, UK, say they are filling the tank. Okay, here once they fill the tank with gasoline, what happens? It overflows because the level high switches got stuck. So what happens? The gasoline overflows from the tank and its vapor stays there and it gets ignited. Okay. So what is the hazard? Because the level switch is not working, maybe they have not maintained it properly. So that is the reason why this got ignited. Okay. How HAZOP is carried out? I said our aim for the HAZOP is to conduct, identify the hazard in it. Okay. How hazard is carried out? Approach to the HAZOP. Our aim is to define the objective of the scope. Okay. To check the design of the new unit, how it's going to work, improve the safety of existing unit, to check the running and operating instruction, to check the modification carried out. Okay, this is our aim. Okay. Okay. Prerequest. What is the prerequest? What is the required document that is there? Our required document for carrying out HAZOP is process design basis and process description, process PFD. Okay. we need to know what is the process. So we need a description for it. Then we need PFD. PFD is nothing but process flow diagram, right? Usually when we say process flow diagram, the diagram contains all the stream, each and the different, it is divided into different streams, and every stream has temperature, pressure, flow, density, all these values will be given in the PFD. Okay, then P&ID, piping and instrument diagram. Okay, then interlock, that is your cause and effect. Then operation, POM, plant operating manual, all operating procedures that you have for the thing, that these are required for carrying out these are the required documents that is required to carry out a HAZOP. Okay, only when you have the know the process, and you know the P&ID, how the flow goes and what are the valves and different equipments in it, so you can know it. And you want to know the interlock, what happens when this valve close, or if the ESG trips, what are the other valve close, you need to have it. And you have to need operational maintenance procedure also. You want to know the plant at least, or to know what will be the cause and consequence of it. Okay. See, as I told you, it can be carried out in the basic engineering stage, detailed engineering, during bottlenecking, during regular operation, and at any time of the project or at any time of your running unit. It can be carried out at any stages. Who are the team members? Usually the chairperson. HAZOP chairperson is no one other than the person who is leads the team, and HAZOP scribe is the person who collects all the information and records it. Process engineer, instrument engineer, safety engineer, production operations engineer and operator, and experienced operator is a must, and the maintenance engineer. Okay, and HAZOP chairman is the person who is going to stimulates, or he leads the team, and he puts the question, and he makes everyone to participate in the discussion. Again, I'll tell you that HAZOP is not also a one-man's job. It is going to be a team effort. The success of the HAZOP depends upon the participation of each and every member. So HAZOP chairman duty is to ensure that every team members participates and contribute effectively for a successful HAZOP. HAZOP preparation. Now let's see how HAZOP is prepared, state is prepared. Okay. See, I will go step by step, dividing the process into a system as per the process intention. Okay. Okay, now you see, I'll explain you. See, first our aim is to take a unit. Okay, any unit. Then you divide it into, you divide it into sections, small sections. Then this small section is broken into small streams. Okay, small streams. And these streams are called as nodes. Okay, first what I'm going to do, I'm going to take a big process. And if possible, I am going to break this process into smaller units, small sections, and I will break the small sections into small streams, and I'm going to every stream, I'm going to call them as a node. Why I'm doing is this, because process industries are a chain of units. Okay, so it is very complicated to everything is interconnected. It is difficult to write as a whole cause and consequence for it. So what I'm going to do I'm going to break it into smaller section, and I am going to apply the deviation and see for each and every node what will be the effect on it. Okay. And we have to ensure that whenever we break it into nodes, we should not see that it is neither too big or not too small. If it is too small, you will have no number of nodes and going to be confusions into that. You will not have effective cause and consequence. If it is very big, you will get confused to it. Okay, so it should not be neither too big, not too small. Is there any thumb rule for dividing the node? No. Whenever there is a phase change or changes, they break the note usually and ensure it depends upon the chairman's and the team's, experience and knowledge. Okay, here note selection. See, if I see the phase that you get is going to be in red, the upstream and the downstream, the gas phase and the liquid phase is carried out as one node. Okay, node one. And if you see, there is another line that is going out, that is to node 2 blue. Okay, and there is another line that is just going out. This line is also node 3. So you separate it in such a way based on the experience of the chairman. Chairman is the person who decides the nodes and he floats the nodes across the team for the consciousness. Okay, next one. Okay. Key terms in HAZOP and procedure. See, we will see what are the key terms, then we'll go node, parameter, guided word, cause, consequence, safeguards, and recommendation. These are the some of the terms that is used frequently in HAZOP. So let's go one by one. Okay. Okay, note. As I told you, we break it into smaller thing for for the convenient and to be more efficient. Those small streams are called as node. Okay. Then what are parameters? Parameters, as flow, temperature, pressure, level, others, composition. All those things are some of the parameters that is used. Okay. And we use a word called as guided words. The guided words are nothing but no, more, less, as well as reverse, other than, others. These are the guided words. Okay. So when I combine the guide word and the parameter, then it becomes a deviation. See, I take a small flow, a node. Okay. Say liquid is coming, liquid outlet of a separator. That is my node. Okay. So what I do, I apply the deviation. How I have to apply the deviation? I say I take the parameter flow. First, we usually in HAZOP mostly we take the flow. Why? When we take the flow, we are going to cover all the pressure, temperature, okay, pressure, temperature, level, directly or indirectly. So my first deviation usually used to be parameter. How I am going to take my guide word is going to be no. First, I'll take no or less. No flow from the separator. Okay, I'll take the deviation. So what will be the cause for it? I'll write it. Next, I'll see. So my deviation is nothing but guided word plus the parameter. Parameter plus guided, no flow. Okay, less temperature, more pressure, less pressure. So this will be my deviation. So I apply this deviation to the node. Okay, deviations, I told you, right? Parameter, flow, okay, design, temperature, okay, more temperature, less temperature. Okay, these are the guided word. These are some of the example for deviations. Then we have to write the cost. Before I take the node, after taking the node, I am just giving applying the deviation to the node. Okay, I say more flow. Okay, say more flow of condensate. Okay, this is my to the more flow of condensate to the separator. This is my deviation, and I have to say what is causing this deviation, right? When I say there is a deviation, then I find I'm going to give the cause. This is the reason. Oh, I'll say these are the conditions. I'll say maybe for more flow, I say the control valve was opened fully. That will be the one of the cause. Suppose there is no flow, I'll say pump has tripped, valve was closed. So this is going to be the cause. Whatever there is a cause that causes the deviation, I am going to write. First, I'll write the deviation, then I'll write the cause. What has caused this deviation? Okay, that is what I'm going to do. After that, I am going to write the consequence. Okay. See, first, I have written what? I have written my cause. Okay. Now I am going to write the consequence. Consequence is nothing but what happens. Suppose if if there is no flow outlet of the separator, what happens? The level is going to increase. When the level increases, what will happen? See, I should not say simply write level as raise in the separator. It has to be some result in some hazard. Maybe it will pressurize the vessel. Okay, over pressurization of the vessel, or it must lead to some LOC. Okay, carry over of liquid to the flare header. So these are the consequence. The consequence must be in such a way you define the leading to an hazard. Okay, that is the aim. What will be the consequence? Okay, consequence over pressurization, vacuum formation, for damage to the pump, because these, when I say overpression, maybe there is overpression leading to explosion, damage to the equipment. Okay, when I say pump no level in the vessel, I'll say damage to the pump. Okay, off spec product, some LOC must be there, or upsets, but I just it has to be resulting in some damage. It has to, we have to write the consequence. Okay, safeguards. When I say safeguard, when I say safeguard, I have to write process, okay, procedure, alarms, okay, process, the well-designed process also one of the safeguard. Another one is procedures and alarms. Okay, alarms is nothing but whenever there is a deviation, there is an alarm followed by the action by the operator. Then safety instrumented system, nothing but the SIF. Then mechanical safety is nothing but your PSV and integrative and passive dyke wall, all those things, or your firewall, all or your inherent passive systems. Next one, typical safeguard, right? The PSVs, interlock, I told you, alarms, all those things are your safeguard. See, when we say after putting the safeguard, then we do risk, something called as risk ranking. I will describe. Then we come in for, suppose still there is the risk is high, then we come out for the recommendation. Okay, to reduce it. Okay, next one. Okay, action plan. Okay. Okay, like how the recommendation can be procedural or engineering, okay, or soft alarms, then hardware changes, any changes that can be done, or design, review of the design. If the thing is done, then these are all some of the recommendation how it has to be. How HAZOP has to be. Okay, now our aim, we have to see. HAZOP is nothing but, I told you, it's a brainstorming section, right? See, our aim is to find the only the hazard. Our aim is not to discuss whether it is design aspect, all those things, unnecessary discussion that will be carried out when a group of people come together. That has to be as a that has to be avoided, and we have to stick to the time frame. Okay. Okay, these are some of the common conditions that think simultaneous. These are things that should not be two simultaneous, means two different incidents that is happening at the same time. It should not be considered. Operation negligence, operator is not doing mistake, should not be considered. Sabotage means someone attacked doing cyber security or something, that will not be considered. Okay, flood, it is not considered. Design work will be done. Okay, no design, discussing about the design and HAZOP should be done. Okay, we should not take the failure of the ultimate safeguard like PSV. Okay, if you do for one, if there are two identical systems, if you do HAZOP for one system, the other one is considered done. Okay, you can change only the tag numbers. Okay. Okay. Following interlock, shutdown, alarm. This, as I told you in the previous slide, these are some of the safeguards that is there. Already we have seen it. Okay. Whether it's what are the things that should be considered? Single block valve, check valve, NRV is considered safe. Unless and otherwise, it is going to lead to over pressurization of the system. Other than then, one safe NRV is sufficient to protect the reverse flow. As I say, simultaneous failure, it should not be considered. Okay. Intention of research study is not to become a redesign meeting. You should not. It's not the place to discuss about the design. pitfalls. What are the pitfalls? Shortcomings. Error identification. If you are poor in identifying hazard, okay, you don't have a clear P and ID, inexperienced hazard team, unrealistic study. You complete 10 nodes in a day, then it is unrealistic. Having nothing, lack of interest and biased approach. Lack of interest is nothing but see, HAZOP is a laborious process. Okay, it is monotonous. You keep on doing it, then you lag some interest. People lose the interest. Unbiased approach means if a person you take sides, you go side along with the operation, or sometimes a process engineering or instrument. As a chairman, as a person who does not take side. Okay, he has to facilitate the meeting. HAZOP common mistakes. Okay, failure to create an open environment. Okay, undue credit for safeguard. Whatever there is a credit, there is certain rules for giving credit. All those credit should be given. Okay, and whatever there is built-in design that has to be taken. Open-ended recommendations should not be there. Inadequate documentation. Little attention to startup and shutdown. HAZOP as a substitute for design review. It should not be. These are the mistakes. The most important thing is risk ranking. Okay, as we discussed, risk is nothing but severity, product of severity and likelihood. Okay, so see, this is how, this changes from organization to organization. We this is the common how it is being done. This is not a fixed one. Okay, so this is just an example for, we say, the Caltex C1, C2, C3, C4. Okay, it depends upon the matrix. Some stop at C4 itself. 3x4x4 matrix also. Okay, see, extensive. This is for the asset damage. They take the damage in terms of injury, personal peer. I said right here. This is damage to the asset, and this is to the environment. And reputation, usually they don't take it during the HAZOP mostly, because some companies mostly they don't take it because it is difficult to quantify the loss because of the impact on the reputation. Okay, how far it is going to be. Likelihood, how likelihood they take this likelihood based on the history of the organization. Okay, and sometimes they take it if it is within one organization, they take it. If it is a group of companies, they take it across the organization. Okay, some people they go way behind it and they look into other industries around the thing and they take it. Okay, this is how the matrix looks like. Okay, likelihood versus severity. Wherever you fall within this green range, it is accepted. Okay, this yellow is also, it is in the ALAP is accepted. This unacceptable range is the red. Whenever you fall in the unacceptable range, then you go for the recommendation. HAZOP software, I told you there are different software. The software helps in carrying out your job easily. Okay, it is resourceful and it automatically generates the report, and it is easy, right? You can just refer the same cause and consequence if it is there. So it will be easy and you can put in the files also. So advantage of this software, there are PHA work, PHA Pro, PHA Leader, all those things are there. Software, different softwares are available in the market now. Okay, HAZOP, this is how the HAZOP worksheet looks like. Okay, as I said, it's going to be your guide words, deviation, cause, consequence, and safeguards. Okay, that's it. Thank you for listening patiently. Okay, if there is any question, I'll be pleased to answer it.
Thank you, sir. Thank you for this session.
Welcome.
If you have questions, kindly post the questions in the link that I've shared. We have got a couple of questions. We'll address them. The first question is, at what stage HAZOP study will be conducted? What are the inputs required and who are usually involved in the studies?
Ma'am, I have told you, it has different stages. Even feed stage, detailed engineering stage, commissioning, then operation, and every 5 years. Okay, that I think I have addressed it. And who will be chair? There will be a chairperson Okay, a very experienced chairperson who is an HAZOP facilitator or HAZOP chairman, and it has to be from different team. Mostly it is from operations, process engineering, instrumentation, loss prevention, and and other discipline safety. Take part in it. It is hardly they stick to 8 to maximum of 8 to 10 people, not more than that.
Okay, sir. Next question. Can you explain the HAZOP worksheet?
See, I think where is the workshop? Yeah. See, you HAZOP worksheet again. How I'll tell you. This is the guided word. Guide word is nothing but I told you, right? Guide word is no or less. There are certain specifics given, no or less, more flow, then less, more, less, all those things are guided words. I put the guide words first, say here I have taken no. Then the deviation is nothing but no flow. Flow usually when they carry out the HAZOP, usually the parameter is going to be flow. Parameters is nothing but your process variables in short, okay, in terms. They say no flow. This is the deviation. I have given I'll say no flow of here. I have taken no flow of fuel gas. Okay, so this is my deviation. So I want to know what is causing this deviation. Say here they write the cause as no fuel gas from the battery limit. Means the upstream some plant has tripped or there is some problem. So you're not getting the fuel gas. So when I don't get the fuel gas, I write what are the consequence of it. Okay. So there is no steam produced. So there is going to be a different startup or there is going to be a trip. So production loss. So I write it. So what will be the safeguard for it? Maybe there will be an alarm for it when I get the flow so that I can make another arrangement for it. So this is how it goes. Hope this assists. Or this is how the worksheet is. Okay. Next one, ma'am.
Next question. What is the scope of hazard compared to HAZOP?
Okay, see, Azid is mostly carried out during the project stage. It describes both what is going to happen during the project and in the process. It is not specific to the process only. Okay, it is involves during the startup of the project. You write what are the different guided words are there. You take here there storm, wind, everything. Okay, landslide, erosion, corrosion, everything is being divided related to the project and also some related to the process also. So it is carried out during the early stages of the project. HAZOP is specific to the process and it is carried out during the execution of the design process, as I said before. Yes, ma'am. Next one.
What is the difference in HAZOP study in basic engineering and detail engineering phases?
See, in basic, you don't have much of the engineering, right? So you find in the basic, there is not going to be much of the P and ID, right? So you come out with much of the recommendation with it. As you give the recommendation and you develop more of the P and IDs, again, you review all those safeguards and everything that you have incorporated, whether those are sufficient. Next one.
Okay, difference between SIF and SIS.
This is HAZOP, but still I'll tell you. SIF is safety instrumented system. SIF is safety instrumented function. Okay, a safety instrumented function. SIS is nothing but a combination of SIF. Multiple SIF is nothing but SIS. Okay.
What are the softwares used for HAZOP study?
I told you PHA Pro, PHA works mostly. We are using it.
Any other questions, anyone? We have addressed whatever has been posted. If you have more questions, you can unmute yourself and ask. Any more questions? You can post in the chat box as well. One question, do we have to justify our node selection? What is the classification reasons?
Okay, see, I told you there is no thumb rule for any node selection, right? It is based on the experience, and you have to ensure that the node is neither too small or not, too big. Okay, when you going to it is too big, you are not going to be, you cannot capture the cause and consequence properly. Okay, if it's too small, you're not going to capture it, all the cause and consequence effectively. So it has to be, medium sized, and you have to be usually they stick on whenever there is a phase change, they break the node. Okay, it is based on the experience of the HAZOP chairman, and if he floats it, and mostly it is accepted.
Next question. Which drawing is required for HAZOP?
See, I told you PFD, P&ID is very essential. Process flow diagram and P&ID, process piping and instrument diagram.
Okay, sir. Any more questions? If you have questions, please unmute yourself and ask, or ask in chat box. If there's no question, we'll wind up the session. Your attendance link is posted in the chat. So one more question. Which is the finalized format of HAZOP in feed or basic engineering?
Feed, see, basic feed, the final HAZOP thing is only during the commissioning and the running operational phase. Until commissioning and startup phase, they keep doing the HAZOP at different stages. Okay, mostly they carry it out only during the when one detailed engineering is done, they carry it out mostly.
Okay, sir. Any more questions? You can mark your attendance. The link is shared in the chat box. You'll be having the assessment of this module tomorrow. Mr. Muttu, if you have, I'm not sure about the question, can you unmute yourself and ask? Your question is not clear, so can you unmute yourself and ask? So question, at what stage the HAZOP comments will be freezed? 30% review or after 60%?
See, I told you, right? The HAZOP comments is there is no as such freezing, right? When we finish the HAZOP, the comments is going to be taken and it has to be incorporated, right? So at 60% also completion, there is going to be HAZOP again.
Okay, sir. Any more questions, anyone? Or we'll conclude the session if you have no questions. Sir, I think there is no more questions. We can conclude today's session.
Okay.
Thank you so much for connecting with us in this short period. And thank you everyone for connecting today. You'll be having the assessment for this module tomorrow. And tomorrow you'll be having training, the usual time. So make note of that. Thank you, sir. Thank you, everyone.
Thank you very much. Thank you.